All right, today we are going to be doing stoichiometry, and the stoichiometry has to do with the balance equation. So let me go ahead and write the title here, and it's going to be called Stoichiometry. And by the way, I don't know if I mentioned this enough. I'm really proud of you. I'm very proud of you. That last test, I don't care what you say, even the people that got A's, that was not an easy test. Some of you made it look easy, but you had to work. You had to work on that chapter to get an A, even a B. To get an A or a B, you had to work pretty hard. And I'm really proud of you. So you're doing great. I do not think that was easy. So all right, so now what we're going to do is we're going to use the same idea that you had from last chapter, and we're going to apply it to not just changing molecules to moles or something like that, but to actually say, let's do something with it. And they do it in the real world. They actually use this right here. All right, so let me go ahead and I'm going to pick an equation they have in a book, and I'm going to write it out for you. It says C3H8 plus oxygen okay, now do you think you don't know the name of this? Whenever you have carbon chemistry, carbon hydrogen compounds, we're talking about organic chemistry. Most of first year chemistry is called inorganic, metal, non-metal, ions, that kind of stuff. But organic chemistry is where they deal with carbon compounds, so that's why you don't know the name of that. And it just so happens, I'll even tell you the name right here. This has 3 carbons in it, and it's called propane. Now, have you ever heard of propane gas? How many of you have a propane tank at home, like with your barbecue grill? Okay, so that's what's in there. What's in there is C3H8. It's called propane. And if you let that gas out and you put a spark onto it, you can burn it. So aren't we burning it? So we're burning this hydrocarbon. A compound that only has carbon and hydrogen is called a hydrocarbon. So you're going to burn a hydrocarbon. And remember this, how would you classify this equation? What type of a reaction is it? Combustion, isn't it? Isn't it burning of a carbon-hydrogen compound? And what are the 2 products I should get? Okay, so I like that one, all right? So we're going to use that as our basic idea, and let's go ahead and balance it. See if you can balance this equation. See if you can balance this equation. It's been a little while since we've done that, hasn't it? Anybody have any tricks or anything? What do you think? I noticed there are 8 hydrogens here. Is it okay to put an even number in front of water on a compound? That'll work. That'll probably work. And then what about carbons? Okay, I'll try that. I'll try that. How many oxygens over here? 6 plus what? That's 10. Ooh, I think I can do that. All right, what do you think? Okay, I'm balancing? Okay, now you might ask yourself, well, what's new? I thought we were doing something new. Well, we are, okay. I'm going to make up a number, and I'm going to make this up, okay, if you want to know where it came from. I'm going to start with 100 grams of propane. And you say, where'd you get that? I just made it up, okay? I just made it up. Here's my question. I want to know how many grams of oxygen are going to react with 100 grams of propane. And I'm going to ask you this. How many grams of carbon dioxide are produced after you burn it? And then I want to ask you, how many grams of water are produced when you burn it? Now, we've never done anything like that, have we? We've never done it, right? All right, so here we go. This is going to be a weird lesson. Okay, let me show you how it's weird. You see this right here? I think I should be able to go from here right over here. I should be able to go from here over to here. Don't you think so? That'd be pretty fast. If I take this number here and do something to it, I should be able to get that number here, shouldn't I? But you can't. You can't. I'm going to tell you why. You can't do it because there's a tree there. So you can't. You can't go from grams to grams. Why not? There's a tree there. It's a chemistry. So the reason I want you to remember that is it looks logical to simply go from grams to grams, but you can't. What if I have the grams here? What if I want to go from grams to that to that? You can't, because there's a brick wall there. Brick wall. I've never drawn a brick wall before in my life. You can't do it. Okay, you can't go from grams to grams. I want to go from grams to this to grams to that. You can't. There's a big city there. There's a city there. No, you can't. You can't do that. Now, first of all, you say to yourself, this is weird. This is pretty weird. I've never seen in a chemistry book where they draw a tree or a brick wall or a city. I don't understand what you're doing here. Well, so what I'm going to do is I want to show you something that's pretty neat. If I want to go from here to there, I can't. But what I could do, what if I could dig a tunnel down here? What if I could dig a tunnel down here and go into this world that's underground? What if I went underground? And you know who lives underground? Moles. I want to go down into the mole world because moles live underground. Now watch. I could go down in the mole world, dig another tunnel in the mole world, and then dig a tunnel back up. And I could do it. If the tree's in my way, I could go underground. And I know this sounds weird to do this. You said, are you teaching chemistry? What are you teaching here? And I am. I'm trying to teach you chemistry. But I want to tell you something here. If you know exactly what I just said here, here's what you know to do. Step 1. Step 2. Step 3. And I'm going to show you in 3 steps how to find that number right there. All right, so let's try it. Number 1. If you can tell me in words, what am I doing when I go from here to there? If you tell it to me in words, you're going to understand my lesson. And by the way, I'm going to show you how to do this called the long cut, and I'm going to show you the shortcut. Got it? So this problem's going to take a little while because I'm going to show you the long cut. All right, anybody want to try that? In words, what do you think I'm doing when I go from here to here? Who wants to try it? Just take a chance. He said, I don't know what you're looking for, but I think I know what you might want to say. What do you think I want to say here?
You're converting from
Grams of what?
grams of protein to moles of protein.
Oh, that's right. So step number 1 is change grams of propane into what? Moles. I'm in the mole world, aren't I, down here? Isn't that where moles live? All right, so, hey, I've done that before. And first of all, let's go ahead and write this because I know I started with 100 grams of that. But how do I do that? Let's see, what do I know about propane? 1 mole of propane equals 6.02 times 10 to the 23rd Somebody said it. And why is it molecules? Because that's a non-metal, isn't it? equals what? So 1 mole of propane equals 6.02 times 10 to the 23rd molecules of propane equals, we're going to do some molar masses here. Let's do some molar masses because we're going to use them anyway. What's the molar mass of C3H8? What's the molar mass of O2? What's the molar mass of CO2? And what's the molar mass of H2O? All right, let's try it. Let's go down the road. Ty, what do you think the molar mass of this guy is? Say it again.
44.
Ooh, how'd you get that?
C is 12.
That's 36. And 36 and 8 is what? That was fast and very good. All right, let's go down the road. Elizabeth, molar mass of O2.
32.
Nice. All right, CO2. Danielle.
44.
That's a coincidence. And water?
18.
You guys are getting so good. You're becoming chemistry students. Now, let's go here. You said 1 mole of that is 44 grams. Okay. Now, if you go ahead and put this in your calculator, I've said this many times. I don't care how many, well, I do care. Don't do any calculations in here that drop below 3 sig figs if you can help it. If you can help it, don't go below 3 sig figs. So what is 100 divided by 44? Max, you're pretty fast at this. I'll bet it's 2 point something.
Yeah, 2.27.
What is it, 7?
2.27.
Okay, and that's rounded off. The next figure made the 7 go up by 1 or it stayed 7?
Just say the same.
All right, is everybody okay on that? 2.27? Now, I'm not done yet, because now, watch now, I'll call on somebody else. Tyler, you can do this. Look at I just went step 1. I just did step 1 here. Now I want to do step 2. Now this is something you've never done. What we're doing right now, but if Tyler would tell me what I'm converting what into what, I'll show you how this works, okay? What am I doing, Tyler, if I'm going to go from here to here? Say it in words. Moles of what? Okay, moles of propane, and change it into what? No, what world are you in? You're underground. That's where moles live. So change moles of propane into what? Moles of oxygen. Whoa, whoa, I've never done that before. All right, so I'll show you a little trick, okay? Everybody with me? You know where these numbers came from, right? If you want to go from grams to moles, you already know how to do that, don't you? This is something new. When you go in the mole world, if you go from moles to moles of another chemical, that's when you use the coefficients of the balance equation. So what you do, this is called a mole ratio, and you get it from the coefficients. Now, I didn't do this. God did this, okay? Here's what God did. God said, can 1 mole of this react with 1 mole of that? He said, no. No, my plan is not for 1 to 1. No. Can 1 mole of that react with 2 moles of that? No. If you want 1 mole of that to completely react with oxygen, you better give me how many? And that's why it's called a mole ratio. Watch this now. For every 1 mole of propane, you must have how many available? You must have 5 moles of oxygen to completely react with it. Oh, that's what the coefficients are for. Now go ahead and put that in a calculator. I bet you've already done it, haven't you? Do you have a calculator with you today?
Yeah.
If you guys are punching numbers in on a calculator, then if you make a mistake, you'll know you made a mistake. But if you're sitting there and not calculating, you won't even know you made a mistake. John, do you already have this number?
Yeah,
What do you got?
11.36.
11.36?
Yeah.
Okay. Everybody okay on that? Yes, no?
Do you want us to round to just 11.4?
You could. Just don't drop below 3. If you want to hang on to 4, you can. Just tell yourself, don't drop below 3. How about that? So if you want to put 11.4, you can do that. And now, one more. This was step 2, and here's step 3. So this was step 2, and you've never done that before. You've never changed moles of something to moles of another chemical. That's what they have a balanced equation. Step 3. Let me ask, let's see, Jonathan. Jonathan, in words, what are you doing when you go from here to there? What do you, tell me in words what I'm doing. What am I trying to change what into what? Of, into, of, yes. If you can say it in words, it'll make sense with factor label. Now, see this guy here? You're going to change moles of O2 into grams of O2, right? Everybody got that? Now, you probably have already figured out that when you go up or down in the mole world, you use molar masses, don't you? What if I go sideways in the mole world? I don't use molar masses, I use the coefficients. Ooh, interesting. So what am I going to put here? 1 mole O2 is what? Okay, here we go. Let's find out. How many grams of oxygen will react with 100 grams of propane? And all you do is you can either you just put this in your calculator, and we should get a final answer right here. All right, who has this? Davis, do you have it?
Yeah.
What do you got?
363,
353,
363.
0.64. Wow, that's pretty detailed. I'll just put 0.6, okay? Now, 363.6 grams. Now, again, one more time. Why didn't I just go from 100 grams and figure out how to go from grams to grams up here? Why didn't I do that? How come I can't just go from grams of propane and figure out how many grams of O2? How come I can't do that? What do you think? Noah, what do you think? How come I can't do that? Because there's a tree in the way. And I want you to remember that. It's stupid, isn't it? It's stupid. You can't go from grams of this to grams of that. Just tell yourself, I can't. There's a tree in the way. So we have to do it this way. Grams of this to moles of that. Moles of that to moles of that. Moles of that into grams of that. That's how you have to do it. Okay. Let's do it again. Now, I would like to find out how many grams of carbon dioxide are going to be produced. So let's do that one. Let's do another problem. Now, here's what's neat about this method. What do you want to start with your given? What do you want to start with? Shouldn't I start with this? I can. I can start with this. Could I start with this? As long as I made my calculation correct, can I start with this? Yes. Could I start with this? Yes. Could I start with this? Yes. The only problem is, if you make a mistake right here, then all these numbers are wrong. You get that? So I'll try it the other way just to make you feel comfortable. But a lot of you are going to say, no, I'm not going to make mistakes here. I could start with any of these numbers. You know what? If you start here, it's going to take the longest time. If you start here, it takes you the shortest amount of time. So let's do it anyway. Which way do you want to go? You want to start with this guy? Let's try it. Erase that. Let's start with this one given. 11.36 what? What's that say? What label is this? Come on, that's where moles live, right? All right, so moles of O2, that's my given. And what do you want to do? I want to find this. I want to find this. Well, what do you have to do? You gotta go here, dig a tunnel, dig, 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 dig. Okay. All right. So, Kayla, I haven't called you yet. Tell me in words what I have to do to go from here to there. Change what into what? Of? Yes? Yes, yes, yes. So guess what? I want to change moles of O2, and you want to change it into moles of CO2, right? Yeah, now this is the first day we've done this, okay? Where am I going to get my numbers for this? Am I going to use molar mass for this? No. When I go up or down, I use molar mass. But when I go sideways, where do I get my numbers? You're going to forget this because this is the first day you've ever learned it. But where do I get my numbers when I want to go sideways in the mole world? Oh. God said for every 5 moles of oxygen, it will produce, in this equation, it will produce what? 3 moles of carbon dioxide. I didn't do it. I didn't do that. But the balanced equation tells me that's how the mole ratio works. This is the mole ratio, isn't it? Isn't that the mole ratio? And that's your coefficients, aren't they? All right, go ahead and put that in the calculator. And when I get done, even though this problem takes a long time to do, I'm going to have you clear your calculators, and I'm going to show you how to do this problem in 1/10 of the time. I don't want to show you a shortcut right now. I'll show it to you later. You already know the shortcut? You already figured out the shortcut? Okay, all right. We'll do the shortcut in a minute, okay? All right, what do you got? Who am I calling? Who am I calling? Noah Ramos. What do you got? I know this number is going to be smaller than that number, so what is it? 6.8 what?
816.
That'd be 2 then. 6.82? Okay, is everybody okay on that? Did everybody get that? Raise your hand if you didn't get that. All right, now, we got to go another step, and Kaylee did such a good job, I'll let you do the next step too. What do you want to do from here? Say it, tell me to in words. In words. Change what? Yes. Yes. And do you know about what numbers? Can you help me? What do I put here? Excellent, excellent, excellent. All right, go ahead and put that in the calculator. Do you already have it? Oh, okay. Did I have it yet? So it's this number times that number, divide by that number, times that number. If you get bored, this number times that number, times that number, divide by that number. If you get bored, this number times this number, divide by that number, times, okay. What do you got? I got to hurry here a little bit. Who has it already? Do you have it? What do you got? 299?
Yeah,
0.9. Now, did you know that if you start with 100 grams of propane and you burn it, you should get about very close to 300 grams of carbon dioxide produced. All right, let's do one more, and then I will show you the shortcut. I will make you use long cut the first time I give you a quiz on this, like next week. I will make you use the factor label method, get it? And then later I'll say, now you can use shortcut, get it? But not yet. All right, so this came out to be 299.9 grams of CO2. All right, now I want to find grams of water, and what do you want to start with? What do you think I should start with my given? If I start here, I have to do 1 conversion factor. Watch now, it's kind of neat, the mole world, watch. 1 conversion factor, whoa! You can go all the way over here. You can go, whoa! And if you want to do that in the mole world, but it takes you 1 step, 2 steps, 3 steps. Or what could I do? What if I start with this stuff? 1 step, 2 steps. Ooh, I'll do that. Now, what is the only danger of what I'm just doing right now? What's the danger of what I'm doing? What would be bad for me to start with this?
Did something wrong.
If you made a mistake at the very beginning, guess what? All your numbers are wrong. Get that? But if we're careful, if we take our time, and you said, no, I didn't make a mistake, then we should be able to do that. All right, let's go with, all right, Madeline, tell me in words, how do you go from here to there? What are you trying to do in words? Change what? Moles of what?
Carbon dioxide
Yes.
to
You're in the mole world. Aren't you underground?
yes.
Yes. Of what? Okay, now, here's the tricky part, Madeline. Where do I get numbers for this conversion factor? I'm going from here to this way. How do I get my numbers? And again, this is the first day we've ever done it, so I'm going to remind you about something. Whenever I went up or down into the mole world or out, I used molar mass. But when I go sideways in the mole world, I do not use molar mass. I use what numbers? Yes. Tell me what to put here, what to put here. Very good. Say it again. Here. What number?
For the top one,
Mm-hmm.
4.
Yes. God said in this kind of equation, for every 4 moles of water that are produced, what else will be produced?
3.
3 moles of carbon dioxide. You get that? All right, let's go ahead and we're going to put this, I'm not done yet, sorry. I'm not done yet. Go ahead and put that in the calculator. And I know the number is going to be bigger than 6.82, so does anybody have that? Raise your hand if you already have it. What do you have, Max?
9.09.
09?
Yes.
What do you think? Is everybody getting that? Okay, last one. Last one. Who wants to take me out? Who wants to finish the problem? Who feels really good and said, hey, you didn't call me yet. I want to do this. Thank you, Davis. All right, Davis wants to finish up. Go ahead, Davis. Go. You're going from what to what? Moles of what? You're Mr. Label. What is it?
Water.
Okay. Moles of water to what?
Grams of water.
Yes? And grams of water. How do you get your numbers for that? Okay, so tell me what to put here.
1 mole of water is 18 grams of water.
That's right. All right, and now we can finish it up. And I know some of you, John, I bet you already have it, don't you? What do you have?
163.7.
Now, thank you for being patient with me. I wanted to teach you how this worked. And if that was a problem on the test, how long would it take you to do one problem? What, 15 minutes? You said, wait, I don't think that's going to work very well, is it? And I can actually do this entire problem in under a minute. But I wanted to show you how it worked. Because here's what happens. Let's say eventually you go to college and you take a chemistry class, and you said, oh, I forgot how to do this shortcut. Well, then you're sunk. I'll teach you the shortcut, but you have to promise me, and I'll make you show me the long cut. You get that? You have to show me that if you forget the shortcut, you have something to fall back on. You have a plan that says, I can think my way through it, even if I forget the shortcut. Now, I want you to do one more thing before we get on here. What I want to know is, would you please add these numbers up? What is the mass of the reactants? What's the total mass of the reactants? Too slow. Okay, all right, so is that right? Is that the total mass of the reactants? Wasn't it 363.6 plus 100? Okay, so now tell me the mass of the products. All right, put that in the calculator. What do you get? 473.6. You know, even if it had come out to be 463.4, that's okay. We rounded, didn't we? What did we just find out there? This was something they found out in the 1700s. Remember that guy in that video, Lavoisier? Remember he had like the best balance in the world? He did things like this. And that's why he got credit for the law of conservation of what? Of matter or mass, same thing. And so he said the mass of the reactants have to equal what? The mass of the product. Mass is never lost. It might be changed into another chemical, but you don't lose mass and you don't gain mass out of nowhere either. It has to come from the reactants. So when you're doing these stoichiometry, I know it takes an extra 20 seconds, but if I did one of these problems for homework, and I want to see if I did it right, it wouldn't take very long to add that up and add that up. And if they're not the same, if they're not pretty close to the same, you've made a mistake, hasn't it? If this was 463 and that was like 380, you've made a mistake. So I want to show you that just to say there is a way to check your work, because you did a lot of work, didn't you? Yeah. Would you like to know how to do the shortcut? Okay, now, I promise you, though, the first time I give you a quiz on this, I'll make you do this. You got that? Everybody okay? Okay, because if I teach you just a shortcut, that's a terrible teacher. I have to teach you where this comes from, and you know what? The shortcut's going to make all the difference. It's going to make all the sense in the world. I'll tell you what. Let me use another piece of paper. All right, if you'll clear your calculators, I will show you how to do this problem in under a minute. Let me start with the given. I'm going to start all over again. All right, I want to find this, and this, and this, and this, and this, and this, and this. Okay, and this is my given, right? I'm going to show you how to do this entire problem in under a minute. Oh, no way! That actually took 15 minutes. All right, you think you're ready? Can you handle the truth? You can't handle the truth. No, can you handle the truth? Okay. I'm going to show you how to do this in under a minute. Now, let me show you the trick. Did you know that every time you change grams into moles, even last chapter, you know what you always end up doing? Dividing by the molar mass. Did you know that? Every time you go from grams to moles, you do that. Did you know every time that you go from moles up to grams, you know what you end up doing? You end up multiplying by the molar mass. You do. And when you go from side to side, you look at the coefficients, and I'll show you how to do that too. So do you have a calculator all cleared? Are you ready? Put 100 in there. All right, here's my shortcut. By the way, let's write some molar. Does everybody have the molar masses still written down? Does everybody have the molar masses still written down? I do need the molar masses to do the shortcut. So I'm going to do, write these down again. 44 grams is a molar mass of C3H8, and 32 grams is a molar mass of O2. These are molar masses. And then there's 44 grams, just a coincidence, for CO2, and 18 grams for water. Okay, now I'm ready. Are you ready? I'll start on the 9. How about that? Ready? Calculator's ready? 100 When you go down in the mole world, you divide by the molar mass. Do it. Go. When you go down in the mole world, you divide by the molar mass. Do it. 100 divided by 44. Put that in there. When you go across, watch now, you got to multiply. Now, you have a choice. If I'm going from here to here, I'm going from 1 to 5. Gotta get bigger. Gotta get bigger. Are you going to multiply by 5 over 1 or 1 over 5? Which one's going to make you bigger? Okay, multiply by 5. Go. Gotta get bigger. Gotta get bigger. Everybody got it? Everybody got it? When you go up, 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 out of the mole world, you multiply by the molar mass. Do it. Multiply this by the molar mass of O2. Don't pay attention to that coefficient. We only look at coefficients going sideways. Multiply this times the molar mass of O2. Do it. Now go here. Ready? Go over here. Here. 5, 3, 5, 3. Gotta get smaller. Gotta get smaller. Are you going to multiply by 5 over 3 or 3 over 5? Which one? Which one's going to make you smaller? All right, do it. Multiply by 3/5. Gotta get smaller. Gotta get smaller. This number's gotta get smaller. Ready? Now, when you come up, up, up out of the molar world, what do? Multiply. Multiply by the molar mass. Multiply by 44. Do it. Now we're going this way. 3, 4. Gotta get bigger. Gotta get bigger. Are you going to multiply by 4 over 3 or 3 over 4? Which one's going to make you bigger? 4 over 3. Do it. Multiply this times 4/3. And now, when you go up, up, up out of the molar world, you multiply by the molar mass of water, 18. Do it. Okay. Wow. Wow. Now, you know why the shortcut works? Because I understand how the long cut works. If you don't understand how the long cut works, then you might forget the shortcut. If I forget the shortcut, I always fall back on the long cut. I'll think my way through that. Now, I'm going to give you a problem. I'm going to let you do the shortcut, okay? You want to try it? I'm going to give you a new problem. What time do we get out of here? 5 after? Okay. I'll just pick 100 grams. Are you ready? Oops. Mole world. All right, molar masses of water, 18. Molar mass for hydrogen gas, 2. Molar mass of O2, 32. Are you ready? Let's have a race. Are you ready? Fill in every oval. Fill in every box. I'll give you 1 minute. Go. And you know, this is the first day we've done it. If you're not really on it, it's okay. Don't worry about it. It's day 1. Now, when you go up and down, don't you look at those coefficients. Don't do that. You only look at coefficients when you're going sideways. Yeah, 30 seconds to go. You can do it. You can do it. This is only the first day, okay? Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Did you get it? Now, I know I'm putting a lot of pressure on you, but it's not for a grade or anything right now. But let's say you didn't quite catch on to the shortcut. Let's start again. And ready? When you go down the mole world, you divide by the molar mass of water. Don't look at that 2. Don't look at that 2. You only look at the coefficient that goes sideways, right? What's the molar mass of water today? What's the molar mass of water tomorrow? 18. 18. Ready? When you go down the mole world, divide by molar mass. What's 100 divided by 18? 5 point what? 5.5? Okay, ready. Now go across. Ready? Gotta get, matchy, 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 matchy. That saved me some time, didn't it? Did you multiply by 2 over 2? Come on. Huh? Matchy, matchy. Okay, ready. When you come up out of the mole world, what do? Multiply by the molar mass. 11? Is that 11? Okay, now, let's go this way. 2, 1. Gotta get smaller. Multiply by half, right? I got a choice of 2 over 1 or 1 over 2. Gotta get smaller. This number's gotta get smaller. This number here better be half the size of that number. What is it? 2.7 what? 5? Is that right? Okay, then go up. When you go up out of the mole world, multiply by the molar mass of O2, which is 32, and I don't know what that is. What's 2.75 times 32? I have no idea. How much?
88.
Wait, say it again.
88.
I can't hear you.
2 8s.
228?
88.
88. I hate math. Okay. Now, now watch now. Add these up, what do you get? 99? 100? Okay, I'm all right with that. I'm all right with that. A little rounding, right? A little bit of rounding, right? All right, you did a great job. All right, thank you very much. That was a great job. Great, great, great job.